In video 5, we're going to take a look at how we can use the laws of exponents that we've learned in order to solve equations. We can do this to two separate types. The first type is when the variable is in the base of the equation. As you can see in this example here, your x is a base. It's 4x to the 3/2 equals 32. This type of equation, this is probably something you want to write down. The goal of this is to get an exponent of 1. So right now we have an exponent of 3/2. When we look at examples later in this video, our goal is to get an exponent of 1. The second type is when the variable is in the exponent. Like right here you have 3 to the x plus 2 equals 11. Our goal for this is going to be to get the same base. We saw a few of these examples in video 2 when we had problems where we needed to write things as powers of other numbers to get the same base. We're going to use that same strategy for these. So here are two examples of our first type. The variable is in the base. Remember our goal here is to get the exponent to equal 1. So our first example there says x to the 2/3 equals 9. What you want to do first is isolate the variable, which in this case it already is. The x to the 2/3 is over here by itself. In order to get an exponent of 1, I'm going to take x to the 2/3, set that equal to 9. What we want to do is put another exponent here, so we can use the law of exponent for power of a power to multiply those to get 1. So what you'll throw in here is the reciprocal of whatever your exponent is. So you just flip it. In this case, we're going to raise that to the 3/2. That means we also need to raise the other side to the 3/2. Whatever you do to one side, you have to do to the other. That still applies here. So when you multiply, these two are going to cancel. We just get an x on this side. Now 9 to the 3/2, we can put the 2 in the root, although we don't really need it. Take the square root of 9 and then cube that. So this is like video number 4 of those problems. So we get x equals, we know the square root of 9 is 3, and 3 cubed is 27. For the second example over here, we said we need to isolate the variable before we do anything. So your first step here is going to be to divide out this 2. So what we'll be left with is x minus 1 to the negative 1/2 equals 4. I left some space here so we can write in our exponent. I want to raise this entire thing, and again it's just the reciprocal, so if I raise that to the negative second, I also need to raise this side to the negative second. When you multiply these two exponents together, you get a 1, and again our goal is to get that exponent of 1. So once we do that, over this side we just have x minus 1. On the right side, 4 to the negative second, we know is 1 over 4 squared. Hopefully we're getting pretty good at those laws. 1 over 4 squared is 1 over 16. When we add 1 to both sides, we're going to add 1 to this side. On this side we can add 16 over 16. We'll make it easier to do that. So your final answer is x equals 17 over 16. The second type of equation, we said the variable is in the exponent. As you can see here, we have an x on this side here and 2 x's in the exponents on this one. So again, we talked about our goal is to get the same base. That's what we're looking for here. And this is going to be similar to the problems we did in 5.1 on that second video. So over here we have a 9 and a 3 to deal with. We know those are both powers of 3. So I can write 9 as 3 squared. Raise that to the x and set that equal to 3 to the 5th. If I simplify this side and multiply those two things, this is 3 to the 2x equals 3 to the 5th. Now the reason we want to get the same base is because once we do that, since the bases are the same, the exponents need to be the same. So we can just pull that down, write 2x equals 5, and we get our final answer as x equals 5 over 2. The one on the right here is a little bit more complicated. What we're dealing with for our bases here are 1/8 and 4. We know we can write those as powers of 2. So 1/8 is the same as 2 to the negative 3rd. You'd write that as 1 over 2 to the 3rd, which would give you the 1 over the 8. We're going to raise that to the 2 minus x just like it is, and then 4 we rewrite as 2 squared. Raise that to the 2x minus 5. Our next step will be to combine those. This negative 3 needs to be distributed when we multiply. So this is going to be 2 to the negative 6 plus 3x. On this side we'll also distribute. So this will be 2 to the 4x minus 10. Again, we notice now the bases are the same, so we can set these exponents equal to each other. So we have negative 6 plus 3x equals 4x minus 10. If I move these around a little bit, add 10 to both sides, I end up with 4 equals, and if I subtract 3 from both sides, we get our x, and we're all set. Our last example here is definitely a little bit more complicated. They didn't tell us what type of problem it is, but we can see from the x's and the exponents that it's a type 2 based on how we define them. So what we want is to get the same base. We just want to remind ourselves of our goal depending on what type of problem it is. On a quiz or test, I obviously won't tell you what you're looking for. So pretty similar to the last one, our bases again are 1/8 and 4. So we can write those the exact same way. That works out pretty nicely. So here we have 2 to the negative third to the x minus 2, and that's all still in that square root. We'll simplify that further. And then here we can write 4 as 2 squared and raise that to the negative 3x. So our right side's a little bit simpler, so let's just start. Say that's 2 to the negative 6x. Here, the first thing I want to take care of are multiplying these exponents, and again here we'll have to distribute. Then we'll worry about what that square root will do. So to start, we have the square root, and this is going to become 2 to the negative 3x plus 6. Again, we saw similar numbers in the last problem, but this one's going to work out a little bit differently. If I take this up to here to give myself a little bit more space, we know we can rewrite that square root. If I put that 2 in here, if I want to turn that into an exponent, I want to put the 2 in the denominator of the exponent. So I can write this as negative 3x plus 6 all over 2. And we still have that right side of 2 to the negative 6x. If you want to pause and kind of rewatch that step, that's a little bit trickier, but the square root and this little 2 over here, oops, this 2 here, sorry, this just got shifted on me, becomes negative 3x plus 6 over 2. If I can slide that back in view. Okay, so now we're at the point where we can set our exponents equal to each other. You don't have to simplify it all yet. We can solve it straight from here. So negative 3x plus 6 over 2 equals negative 6x. If I multiply by 2 on both sides, I get negative 3x plus 6 equals negative 12x. I add the 3x, I get 6 equals negative 9x. And our final answer is x equals negative 2 over 3. So that one's definitely complicated, a little bit longer. I think the hardest thing is going from, again, this point here and writing that exponent as a denominator of 2. But from there you follow the same thing. Once you have the same bases in this step, you can set the exponents equal to each other and then just use arithmetic to solve for x.